Hi, hello everyone. Welcome back to Akki-Vikki. This is Akshaya, 6th grade. Today, let us start our probability, which is the chapter 14 of the NCERT textbook of 10th class. Okay. Find the probability of getting a head when a coin is tossed once. Also find the probability of getting a tail. Okay, so when tossing a coin, we only have two possible events, which is one of them is head and one of them is tail. So, so now we have only head and tail. So let us write our total outcomes. So total outcomes. Okay. Total outcomes. We have total outcomes equal to head and tail, which means only two possible events. Two, and our successful outcomes, which is favorable outcomes. Favorable outcomes are first getting a head, and we have there is only one possibility of getting a head, so we can just write it as 1. So we can write required probability equal to 1 by 2, and we're also asking for tail, so we can just write p of t equal to 1 minus p of h, p of getting a probability of getting a head, because there are only these two possible events. So you can directly write like this, which is equal to 1 minus, we have probability of getting a head equal to 1 by 2. So we can write this p of t is also equal to 1 by 2. Probability of getting a tail is also equal to 1 by 2, which means the probability of getting a tail or a head is equal. Okay. A bag contains a red ball, a blue ball, and a yellow ball, all the balls being of the same size. Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out the yellow ball? Okay, so there in the bag there is one red ball, one yellow ball, and one blue ball. One red, one yellow, one blue. So we have one red, one yellow, and one blue. So okay, we have these three balls. Now they are asking what is the probability that she takes out the yellow ball. So first let us write the total outcomes. Total outcomes. Total outcomes equal to, we have three balls. So we can write the total outcomes are three ways. And the favorable outcomes are to get a yellow ball. We have only one yellow ball. So the favorable outcomes will be equal to 1. So the required probability equal to 1 by 3. Now the B part is a red ball. So similarly like this, we have total outcomes equal to 3. And so we have total outcomes equal to 3. Now, okay, total outcomes. So total outcomes, we have three balls and we have to take one ball out. So we have three ways. So total outcomes are three ways. Total outcomes are three ways. Now the required the favorable outcomes. The favorable outcomes are equal to taking the red ball out, and we have only one red ball, so only one way to take it out. So it is 1. So we can write required probability equal to 1 by 3. Now the C part, blue ball. Okay, the blue ball. Now we have only three balls over here, so we can just directly write P of B equal to P of B. Okay. P of B equal to P of B equal to 1 minus P of Y plus P of R, which is we can write P of Y minus P of R. So which is equal to 1 minus 1 by 3 minus 1 by 3 equal to 1 by 3. So taking out a ball is also, taking out any ball of in this bag is also equally likely. Okay. Suppose we throw a die once. What is the probability of getting a number greater than 4? Okay, so the dice has 6 numbers, and so total outcomes are 6. the dice has 6 numbers, which are 1, 2, 3, 4, 5 and 6. So we can just, we have total outcomes. Let's write first total outcomes are taking, so we have to roll one number out of these 6 numbers. So we have 6 ways for that. So we can just write total outcomes are 6. And the favorable outcomes. The favorable outcomes are rolling what is the probability of getting a number greater than 4. Greater than 4. So we have only 5 and 6 over here, which are 2. So we have greater than 4 are, numbers greater than 4 are 5 and 6. So taking out one of them has 2 ways. We have 5 and 6. So taking out one of them is 2 ways. We can write is 2 ways. So now let us write our favorable outcomes, which are writing the numbers greater than 4. Okay, so the numbers greater than 4 are greater than 4 are 5 and 6. 5 and 6. So taking out one number of these both numbers has 2 ways. So we can just write our favorable outcomes are 2. Favorable outcomes we have 2 ways. 2 ways. And so the required probability equal to 2 by 6. By simplifying this, we get 1 by 3. 1, 3. So the required probability is 1 by 3. Now the second part. What is the probability of getting a number less than or equal to 4? Okay. So less than or equal to 4 now. So we have we wrote that the numbers greater than 4, we have probability 1 by 3. The other numbers which are not greater than 4 are less than or equal to 4. So the probability of getting numbers less than 4, P of n less than or equal to 4 equal to 1 minus P of the numbers greater than 4. P of n greater than 4. And we have 1 minus, we found that the probability of the numbers greater than 4 are 1 by 3. So we can write this is equal to 2 by 3. The required probability is 2 by 3. Okay. One card is drawn from a well shuffled deck of 52 cards. So the deck of 52 cards has 4 suits. 4 suits which are, okay, it has 4 suits. 4 suits which are, first we have a heart. Okay, one heart. Yeah, one heart, diamond, spade and a club. And these, in each of these suits we have some ranks which are as 2 and the numbers from 2 to 10. And we have 3 face cards which are Jack, Queen and King. Jack, Queen and King. So we have, these are the deck of the cards. Now let us follow our question. Calculate the probability that the card will be an as. Okay, so we have first let us write the total outcomes. So total outcomes are, so we have 52 cards and we have to take one card out. So we have 52 ways for that. We can directly write 52. And the favorable outcomes are to it. The card is to be an as, and we have in each rank we have one as. So in heart we will have one as, then in diamond we will have one as, spade we have, and club also we will have. So we have totally 4 asses. So taking out one as from those as, we have 4 ways. So the favorable outcomes will be 4, and the required probability equal to 4 by 52. And by simplifying this, we have 13. 1 by 13. 1 by 13. Okay. Now D part, not be an as. So in this we have calculated to the card to be an as. We have other one is not to be an as. So you can just write the probability of not an as. Not an A equal to 1 minus the probability of getting an A. P of getting A. P of getting an as, which is equal to 1 minus 1 by 13. 1 minus 1 by 13 equal to 12 by 13. 12 by 13. And next, 2 players, Sangeeta and Reshma, play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. So what is okay, the probability of S winning the match is 0.62. So we have in this tennis match we have two events. One is S winning and other one is R winning. So probability of S to win equal to, they have given that is equal to 0.62. So they're asking what is the probability of Reshma winning the match. So we have two events. So adding those both events will be equal to 1. So we can just directly write P of R to win equal to 1 minus equal to 1 minus P of S winning, which is equal to 0.62. We already know that. Okay, P of S win, which is equal to 1 minus 0.62. 0.62. This is equal to 0.38. 0.38 is the required probability. S and H are friends. What is the probability that both will have different birthdays? Okay, different birthdays. Now we have these two are friends. First, let us write the total outcomes. Both are different birthdays. Second is the same birthday, and we have ignoring a leap year. So we can just consider the year has 365 days. Okay, now first the total outcomes. Let us write the total outcomes. Total outcomes are first for choosing the birthday of S, we have 365 days. It can be any day. So 365 into, suppose her birthday is on 17 into, okay, yeah, her birthday is on 17. This into, next is H. H also has any birthday. So it has also 365 days. 365 days. Let us assume her birthday is on 28. Now, so can we have the possibility of having S birthday? This is S and this is H. So can we have the possibility of having the birthday of S on 28th and having the birthday of H on 17th? These both are different because they have the birthdays are always fixed. So, and we have in this S birthday is on 17 and H's birthday is on 28. But in the second one, we have S birthday is on 28. So these both are different.
This 28 is the birthday of S. H. In previous case, 28 is the birthday of H. Both are not equal. Both are different. So no need to divide with 2.
2. Yes.
Right.
Okay, so we have 365 into 365. Now the favorable outcomes. Favorable outcomes are to have the different birthdays, which means let us take the S has 365 ways. 365 ways. Again, let us okay. 365 ways into H. They are telling the different birthdays, which means it should be 364 because one is already taken to S. So it should be 364. 364. And now again, let us assume her birthday is on 17 and 28. Now this 28, okay, over here 28 and over here 17. Again, these are different because in now over here we have 17 S birthday on 17, but over here we have 28. So these both are different. No need to divide by 2 again.
So 17, 28 and 28, 17 are not to be considered as the same. Because 17 is the birthday of S in first case. And second case, 17 is the birthday of H.
Yeah, 17
birthday of H. So 17, 28 and 28, 17 are to be considered as the different. So no need to divide
by 2. Okay, so the required probability we can write. Required probability equal to 365 into 364. 365 into 364 whole divided by 365 into 365. 365 into 365. Now we can cut this both 365, 365. So required equal to 364 divided by 365. This is the probability of their birthdays are on different days. Now this is the first part. Okay, let us go to the second one. The same birthday. Now we have, for having the different birthdays, the probability is 364 by 365, and we only have 2 events over here also. same birthday or different birthday. And now we have different birthday over here. So we can write P of having the same birthday. P of having the same birthday. Same birthday we okay. P of same birthday equal to 1 minus P of having it on different days. P of having it on different. So this is equal to 1 minus P of having different birthdays at 364 by 365. 364 divided by 365, which is equal to 1 by 365. So required probability is 1 by 365. Over here we have 364 by 365. Okay. There are 40 students in the class 10 of a school, of whom 25. Okay, there are 40 students in a class 10 of school who are 25 are girls and 15 are boys. The class teacher has to select one student as a class representative. Okay, she puts the cards. She writes the names of each student on a separate card. The cards being identical. Then she puts the cards in a bag and stirs them thoroughly, which means she shuffles those cards in that bag. She then draws one card from the bag. What is the probability that the name written on the card is the name of a girl? Okay, first, name of a girl. So let us write the total outcomes. So over here we have 25 are girls, 15 are boys, and there are 40 students. Taking out one card from those 40 cards has 40 ways. So total outcomes are 40 ways. And the favorable outcomes are to get the name of a girl. So you have 25 girls, and getting one card of all of those is 25. Has 25 ways. So we can write this equal to 25. So required probability equal to 25 divided by 40. 25 by 40. By simplifying this, 5 and 8. 5 by 8. The required probability. Okay. Now this is the first one. Let's go to the second part. A boy. What's the probability that the name written on the card is the name of a boy? So again we have total outcomes has 40 ways. Total outcomes 40 ways. And favorable outcomes. Favorable outcomes are of getting a boy. So we have 15 boys over here. Choosing one card of those 15 cards has 15 ways. So favorable outcomes is 15. So required probability equal to 15 by 40. 15 by 40. So we can, by simplifying this, we can write 3, 8. 3 by 8. Or we can calculate this like P of getting a boy equal to P of getting a boy equal to 1 minus P of getting a girl. P of getting a girl, because these two are the only events. So 1 minus 5 by 8 is also equal to 3 by 8. 3 by 8. Okay. A box contains 3 blue, 2 white and 4 red marbles. 3 blue, 2 white and 4 red marbles. If a marble is drawn at random from the box, what is the probability that it will be a white marble? So first we have 3 blue, 2 white and 4 red marbles. So total outcomes are, so totally we have the total marbles are 3 plus 2 plus 4, which is 9 marbles. And choosing one marble from that random has 9 ways. So you can get total outcomes are 9 ways. And the favorable outcomes are to get a white one. To get a white marble, and we have 2 white marbles. Getting one at random has 2 ways. So the favorable outcomes are 2 ways. The required probability equal to 2 by 9. 2 by 9. And now second. What is the probability that it will be a blue marble? Okay. Again the total outcomes equal to again 9. And we have the favorable outcomes. Favorable outcomes are to get a blue marble, and we have 3 blue marbles. Choosing one at random has 3 ways. So the favorable outcomes are 3. Now the probability equal to 3 by 9, and by simplifying this you have 1, 3 is equal to 1 by 3. Okay, 1 by 3. And now third, getting a red marble. Okay, now getting a red marble. Okay, now for this we have only white, blue and red. So probability of getting a red marble is also equal to P of getting a red. P of getting a red equal to 1 minus P of getting a blue marble minus P of getting a white marble. So this is equal to 1 minus P of getting a blue marble 1 by 3 minus P of getting a white marble 2 by 9. So this is equal to 1 minus 3 by 9 minus 2 by 9, which is equal to 4 by 9. 4 by 9. This is the required probability. Harpreet tosses 2 different coins simultaneously. Say one is of two different coins simultaneously. Say one is of 1 rupee and other of 2 rupees. Now what is the probability that she gets at least one head? She gets at least one head. So at least one head means one head or 2 heads. We have at least over here. So we can also write 1 minus getting only tails. So let us write that first. So P of getting at least one head. And okay. H is greater than or equal to 1 minus P of getting both tails. So let us calculate P of getting both tails. So the possibilities over here are P of getting both.
T and N tails are mentioned.
Yeah, okay. Okay, wait.
లేదంటే క్యాపిటల్ టీ రాయాలి.
Okay, wait.
అవుట్కమ్స్ ఎప్పుడైనా కాయిన్ ని హెచ్ అయితే క్యాపిటల్ హెచ్, టీ అయితే క్యాపిటల్ టీ.
P of H greater than or equal to 1 minus P of getting both tails. Both tails. Now let us write the possible. So we have 2 coins simultaneously, which means, and we have 2 outcomes on both of them, head and tail. So we can take example of binary system. So the numbers, we have how many numbers are in the binary, 2-digit binary numbers. We have 2 power to 4. 2-digit binary numbers are 4. So we can just write, okay, 2-digit binary numbers. So we have probability of getting a coin 1 and coin 2. In this we have 2 ways, head or tail. 2 ways, and coin 2 also we have 2 ways. Suppose we got over here head. We got head and over here we got tail. Now getting over here tail and here head. So over here we have coin 1 has H, but over here coin 2 has H. So these both are not equal. These both are different possibilities.
Different groups.
Yeah, different groups.
HT and TH are not to be considered as the same. This C1 and C2 are to be treated as separate groups. Okay, that group is not coming to this group, but this group is not coming to that group. So total number of ways are?
This is equal to 2 into 2, 4. 2 into 2 equal to 4. This is equal to, we have 4 ways. So let us write what those 4 ways are. So we have head, okay, head, tail, okay, tail, head, and tail. So now we want both tails. We have only one possibility of getting both tails.
Two-digit binary system.
Yes.
With head as the 1 and tail as the 0. The possibilities are right. 1 1.
Yeah.
0 0 is started. 0 0.
0 0. 0 1. 0 1 0. And 1 1.
Like this over. You can interlink our coin flipping to the binary
system. Okay. So we want only both tails. We have one possibility of getting that. So total outcomes are equal to normally we have 4 ways. So 4 and favorable outcomes. Favorable outcomes equal to one way. So the required probability equal to 1 by 4. 1 by 4. So now we got P of P of T.
Probability of
Wait. P of T.
P of T and D.
Probability of getting a tail, both tails.
దాని పేరు దాన్ని ఏమని ఇండికేట్ చేసుకున్నావు?
P of both tails.
మరి ఇక్కడ వేరే ఏం రాస్తావు ఏమది?
P of both tails. Yeah, the required probability of getting both tails is 1 by 4. Now we want P of heads at least 1. This is equal to, we can write P of heads greater than or equal to 1 equal to 1 minus 1 by 4. 1 minus 1 by 4 equal to 3 by 4. 3 by 4 is the required probability. In a musical chair game, the person playing the music has been advised to stop playing the music at any time within 2 minutes after she starts playing. What is the probability that the music will stop within the first half minute after starting? So now we have the person playing the music has been advised to stop the music within the 2 minutes after she started the music. And now the probability that they are asking is that she stops the music within the first half minute after she starts it. So we can write total outcomes. First let us write total outcomes. Total outcomes equal to 2 minutes. So 2 minutes, within the 2 minutes we have. So within the 2 minutes we have.
Indicate that on the line plot.
Yeah. Wait. Okay, so this is 0. This point is 0. This point is 2. So this is 1. And now first half minute, which is over here, 1 by 2. And now, so we have to. What is the probability that the music will stop? Which means she will stop the music within the first half minute. Which means over in this part only. In this part only, she will stop the music. So now
total region is
0 from 0 to 2.
Right.
Total region.
Possible region.
Total possible region.
She asked to play.
Stop the music.
Playing in 2 minutes. So total possible region equal to 2 minutes. 2.
The favorable possible region.
Favorable region.
Okay, yeah. Favorable region. Favorable region equal to 0 to 1 by 2, which is 1 by 2. So required probability equal to 1 by 2 whole by 2. 1 by 2 whole divided by 2. One by 2 whole divided by 2, which is equal to 1 by 4.
This is of the time which probability?
Geometrical probability. Okay. A missing helicopter is reported to have crashed somewhere in the rectangular region shown in figure 14.2. So this is the rectangular region. What is the probability that it crashed inside the lake shown in the figure? So this is the lake. So they're asking what is the probability that the helicopter crashed into this lake. So now we have this region. So the probability that we have to write is the area of this region divided by the whole region.
The possible
total possible region.
This is also of the type probability.
Geometrical probability.
Geometrical probability, the total possible region.
The total possible region equal to total possible region. We have that is equal to the area of this whole rectangle, which is 4.5 into 9. 4.5 into 9, which is equal to 40.5. 40.5 and units are kilometers. So kilometer square. 40.5 kilometers square. Now this is the total possible region. Now we have favorable region. Favorable region equal to the area of this lake. Now we have this length 4.5 and this length 2. So this is 4.5 minus 2, which is this is 4.5 minus 2, which is equal to 2.5 kilometers. And this region 9 minus 6. 9 minus 6, which is equal to 3 kilometers. Now this area equal to 3 kilometers into 2.5 kilometers. 3 into 2.5, which is equal to 7.5 kilometers square. 7.5 kilometers square. Okay. So the required probability equal to 7.5 kilometers divided by 7.5 kilometers square divided by 40.5 kilometers square. 40.5 kilometers square. Okay. Now, by simplifying this, we can write 75 by 100 whole divided by 405 by 100. 10. 75 by 10 whole by 405 by 10. And we can cancel the 10 to write 75 divided by 405. And again, by simplifying this, we have this 15 and over here 91. 15 and 91. Yeah, 15 divided by 91 is a required probability. 15 divided by 91. 15 divided by 91. అవదు ఇంకా అవదు.
HCF ఎంత వాడికి 1591
1
91
81 sorry 81 yeah. And now we can still reduce this by this is by 5 over this 27. So the required probability equal to 5 divided by 27. 5 divided by 27. Okay.
If this is the geometrical probability, in previous question, geometrical probability, there you have considered the length.
Yes.
Here you have considered the area. Why?
Because they are asking the region that the helicopter crashed into the lake, and so the helicopter can crash anywhere in the lake.
These are the two-dimensional type.
Yeah.
So we have considered the required possibility is the area. In previous it was
the line. Length.
Means one dimensional.
Yeah,
one dimension. Okay, here we are having two dimensional, length and width. If we get a figure of three-dimensional, there we need to consider
length,
volume.
Yeah, volume.
Okay.
Yes.
Right.
Okay. A carton consists of 100 shirts, of which 88 are good. Of 100 shirts, which are 88 are good, 8 have minor defects, and 4 have major defects. Okay. 88 are good, 8 have minor defects, and 4 have major defects. Jimmy, a trader, will only accept the shirts which are good. Only accept the shirts which are good. But Sujata, another trader, will only reject the shirts which have major defects. So one shirt is drawn at random from the carton. What is the probability that it is acceptable to J? Okay, so it should be acceptable to J. So we have 100 shirts, 88 are good, and J will only accept it if the shirts are good. So the total outcomes are, okay, we have total outcomes, and we can choose any shirt of these 100 shirts. We have 100 ways. And the favorable outcomes. Favorable outcomes are, we have 88 are good and they will only accept the shirts which are good. So 88 ways to choose one shirt from those. So we have required probability. Required probability equal to 88 divided by 100. And by simplifying this, we will get by 4, 22, 25. 22 divided by 25. Okay. Now, what is the probability that it is acceptable to S? So, if it is acceptable to S will only reject the shirts which have major defects, which means that S will accept the shirts which are good and which have minor defects. So the total outcomes are total outcomes.
Total outcomes.
Yeah, total outcomes equal to 100 only. In this also you have 100. And favorable outcomes. Favorable outcomes are 88 plus 8 because she will only accept those shirts. 88 plus 8, 96. 96. So we have required probability. Required probability equal to 96 divided by 100. Again, we're simplifying this by 4. We have 24, 25. 24 divided by 25. 24 by 25. Okay. Two dice, one blue and one grey. Two dice, one blue and one grey are thrown at the same time. Write down all the possible outcomes. Okay, write down all the possible outcomes. What is the probability that the sum of the two numbers appearing on the top of the dice is 8? First, let us write all the possible outcomes. Okay, on one dice, 1, 2, 3, 4, 5, 6. And on the other, 1, 2, 3, 4, 5, 6. So, now let us write the possibilities. 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. And over here, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Next, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. And for this, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Next, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Next, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. These are all the possible outcomes. And now the sum of the two numbers on the dice is 8. So let us find those. We have in ones there is none because the maximum sum is 1, 6, which is 7. Now we have 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. We have 5 possible outcomes for this. So the total outcomes are, first let us write the total outcomes equal to, wait, yes, total outcomes. Total outcomes are, we have we have 36 possible because on one die we have blue and grey, blue die and grey die. So for this, okay, so for blue die we have 6 ways and for grey die we have 6 ways. So if we got the number over here 1 and over here 5, is it so over here 5 and 1, are these both different or same? So over here, the number 5 appeared on B, and over here the number 5 appeared on G.
So 1 comma 5 and 5 comma 1 both are to be considered as the
different.
First one is for the blue die.
Yes.
And set 5 is for the green die.
Yeah.
In second case, 5 is for the blue die.
1 is for the gray die.
Okay, this 5 is not for the previous one because these both are the separate dice. Okay, those outcomes are not allowed to place in the B place. Or these outcomes are not allowed to place in the green side.
Gray side.
Gray side. Okay, so total number of possibilities are 36 only.
Yeah, 36. 36. So we should not divide this by 2. So we have total outcomes 36. And the favorable outcomes we have 5. So the required probability equal to 5 by 36. Okay, now next, equal to 30. Okay, so the maximum possible sum on all of these is the 6 plus 6, which is 12. The maximum possible sum equal to 36 12, but they're asking for 13, so there is no possibilities of getting the sum of the numbers on the dice is 13. So
impossible event.
Yeah, impossible event, which is 0. This one is 0 and less than or equal to 12. Yeah, every die over here, every possible outcome has the sum less than or equal to 12. So we can write the total probability for this is 1. This is 1. Okay.
Or you can write the required probability equal to 1 minus.
Yeah, 1 minus.
Sum greater than 12.
Greater than 12, which is 0.
So 1 minus 0
equal
to 1. This is called sure event.
Yeah, sure event. Okay.
Okay.